All right, hello everybody. Today we are going to be learning a new way to solve quadratics, and it would be by using the quadratic formula. So to start, let's look at the do now. It says solve the following equation. I'm just going to rewrite it. We have j plus 7 squared equals 25. Now, the best way to solve this problem is by using the square root method, because if we square root both sides right away, we can get rid of the square root and the squared. So we'd be left with j plus 5. An important thing to note is that when you have a quadratic, so an exponent of 2, you have to have two answers. To show that, we need to include here a plus and a minus. So you always have a plus and minus when you take the square root of both sides. So I'll write that down. So you must have plus or minus when you square root both sides. Don't forget that. So the square root of 25 is 5. Okay, now the last thing we have to do is to get j by itself. And to do that, we have to subtract 5 on both sides. Now we have to be careful here, okay? When we just subtracted the 5, we cannot combine that with the plus or minus 5 yet. So we write it as such, -5 plus or minus 5. Now we have two answers from this. This is where the plus or minus comes in. So to get our two answers, we split this up. This plus or minus, that gives us our two answers. So the first one would be j equals -5 plus 5. And the second one would be j equals -5 minus 5. -5 plus 5 is 0, and -5 minus 5 is a -10. So our two answers are j equals 0 and j equals -10. Okay, now you also might see your answers written in curly brackets. It would look like this. So it would have a curly bracket, -10, comma 0. Whichever way you see your answer, both of them are exactly the same. So, getting into today's lesson, a quadratic equation is an equation that contains x squared. It's really important that you know this because you need to be able to identify when you have to use these procedures. So far, we've solved them by factoring and by square rooting. Now, these methods are not always going to work. So today we are going to be doing the quadratic formula. So the quadratic formula is right here. It's a very important formula. What's great about it though is you don't have to memorize it. It's given to you on your reference table. So notice the equation has a, b, and c. Okay, that a, b, and c comes from your coefficients of x squared, x, and then your constant at the end. Remember, a constant, that's a term with no variable. So just bringing in some more vocabulary. All right, so a is the number in front of x squared, b is the number in front of x, and c is your constant. Notice it is in standard form. It must be in standard form in order to identify a, b, and c. So let's look at when we can use these different techniques. So by factoring, that only works if you have a quadratic that you can factor. I don't know why this is not calibrated properly, but you get the point. Solving quadratics by square rooting. It only works if you do not have an x term. For example, what we have here, or what we had in the do noun. And quadratic formula will always work, which is why we like it the most. So let's start with an example. It says find the roots. Remember, roots. That is a key word for quadratic of m squared plus, m squared minus 5m equals 14. Now, first things first, we have to set the equation equal to 0. So to set it equal to 0, we have to move the 14 by subtracting 14 on both sides. When we subtract 14 on both sides, we're left with m squared minus 5m minus 14 is equal to 0. Our polynomial is in standard form because it goes from highest to lowest exponent. So what we can do now is identify a, b, and c. So remember, a is the number in front of the squared. There's no number there. If there's no number, there's an imaginary 1. So a is 1. B is the number that's next to m. Notice it is a minus 5, so b is a negative 5. You have to include the sign there. And c is the constant. We have a negative 14, so c is negative 14. Now we have to substitute this into the formula, so let's write the formula first. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Please do not mess up writing the formula. It is given to you, so be very, very careful when you write it. Now we have to plug in all of our numbers. So we have x equals negative. Whenever we substitute or plug in, we always use parentheses. So b was a negative 5. Then we have plus or minus the square root. And we have another b. Always use parentheses, especially for negative numbers. So we have b squared minus 4. A was 1. C was negative 14. Just extend this line. And that was all over 2 times A. A was 1. Okay, now the next thing we are going to do is you are going to plug in everything that's underneath the radical only. Okay, I'm going to draw an arrow to continue my work up here. So, you want your answer to look like this. X equals, you want a number in this box, you need your plus or minus, you need your square root, you want a number under the square root, and then you want a number in the denominator. Okay, so we are going to find what to fill in those 3 boxes with. So this first box here, okay, we have a negative 5. Now, if you don't know what this is, that is okay. In your calculator, you would do negative, parentheses, negative 5, close parentheses. When you press enter, you'll see that that is 5. So in this first box, we have a 5. Okay, now let's see what goes under the radical. To figure out what goes under the radical, we're going to type in everything that's underneath the radical. So we have parentheses negative 5, close parentheses squared, minus 4, parentheses a, which was 1, and c, which was a negative 14. And we get 81. So in this box under the radical, we're going to put an 81. Now the number in here, we have to do 2 times 1, which is just 2. Once you get the number under the radical, you're going to see if you can simplify it. You're not always going to be able to simplify the radical, and that's okay. So next we have x equals, we had a 5 plus or minus. Let's see if we could simplify radical 81. If this becomes a whole number, then we're good. If it stays a radical, you want to keep it as a radical. So it actually becomes 9. So this is 5 plus or minus 9 over 2. Since we have all whole numbers here, we have no more radicals, we can get our 2 answers. To get our 2 answers, we split this up, and we have x equals 5. We use the plus or minus to get our 2 answers, so plus 9 over 2. And the second one would be 5 minus 9 over 2. So you can use mental math if you'd like, or you can use your calculator. I like using the alpha y equals button. Okay, we would have 5 plus 9 over 2. So that first answer here would be x equals 7. To get the second answer, you can actually scroll up, press enter, and you get the same thing again. We just now have to change the plus to a minus, and we get -2. So here, x equals -2. And these are our 2 answers, or our 2 roots for our quadratic. Let's do another example here. It says find the roots of 2k squared plus 7 equals a -9. We just fix that. -9k. All right, first things first, we need to get this equal to 0. So to get it equal to 0, we have to add 9k on both sides. When we do that, that will cancel out. We'll be left with 0 on that side. Just move it over a bit so I have more space. You get 0 on this side. And since nothing combines here, we have 2k squared. I'm going to then put the 9k because this will have to be in standard form. All right, so it's equal to 0. It is in standard form. So now we can identify A, B, and C. So A is what's in front of the squared term. So A equals 2. B is next to the k, so B equals 9. And C is the constant, so C equals 7. Always start by just writing the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So now let's plug in a, b, and c. Remember, when you plug in, you must use parentheses. So x equals negative. Then we're plugging in b. B was 9. Then we had plus or minus the square roots. Then we come across b squared, which is 9 squared, minus 4. We have to plug in a, which is 2. We have to plug in c, which is 7. All over 2 times a, which is 2. So remember, we need to simplify this so we have 3 numbers. Okay, so I'm going to bring my work up here. So we have x equals. We want a number here. We want the plus or minus. We want the square root. We want the number underneath the radical. And we want the number in the denominator. So here we have x equals, in that first box, I'll just use the box, I won't write it again. In that first box, we look at what's right over here. We have -9. So in that first box goes a -9. Then we have plus or minus. In our calculator, we're going to find what goes underneath the radical. So you do not type the radical in your calculator. So you have 9 squared minus 4, parentheses 2, parentheses 7. Again, the radical is not in your calculator. So this becomes a 25 underneath the radical. And in the denominator, we have to do 2 times 2, which is 4. Next thing we should check is if we can simplify the number under the radical. So if we can find the square root of 25, if you check in your calculator the square root of 25, it gives us a whole number. It gives us 5. So we are going to change the square root of 25 to 5. To get our two answers, we have to use that plus and minus. So we have x equals -9 plus 5 over 4. And we have x equals -9 minus 5 over 4. So we can use our calculators to find out what that number is. So alpha, y equals, I highly suggest using this button, -9 plus 5 over 4. So our first answer here would be x equals -1. And then we do it for the minus. Again, you can scroll over, press enter, and then scroll back to change the plus to minus. And we get -7 over 2. So x equals -7 over 2. And it is totally fine if you get a fraction as your answer. All right, moving on. Let's try to do one more. So it says, find the roots of 3x squared plus 5x plus 2 equals 14. All right, so first things first, we need to get it equal to 0, so we have to subtract 14 on both sides. Now, since 14 is a number, we're going to subtract it from the 2 because there's no variable attached to it. So we have 3x squared plus 5x. 2 minus 14 is a -12. Since it's equal to 0 and now in standard form, we identify A, B, and C. In this case, A will be 3, B will be 5, and C will be -12. Don't forget the sign that goes with it. So we start by writing the standard quadratic formula. Again, you want to do this every time so you know exactly what you're plugging in. All right, so let's now plug in A, B, and C. So we have x equals negative. For B, we're putting in 5. Always use parentheses. The square root of B squared. So 5 squared minus 4. A is 3. C is -12. This is all over 2 times A, which is 3. Next thing we want to do, I'll bring this up here, is we want to get 3 different numbers. So we want x equals, we want a number here, we want the plus or minus, we want the number under the radical, and we want the number in the denominator. You don't have to always put boxes there, obviously. If you like it, you can continue doing that. So in the first box, we have a -5, so this is just a -5. Underneath the radical, we go to our calculator, we do 5 squared minus 4 times 3 times -12, and we get 169. So we have 169 under there, and in the denominator we have 2 times 3, which is 6. So now let's see if we could simplify the square root of 169. So the square root of that number actually is 13. So we can simplify this further to x equals -5 plus or minus 13 over 6. Since we have all whole numbers and we have no radicals, we can split this up to get two answers. So we have x equals -5 plus 13 over 6, and we have x equals -5 minus 13 over 6. So we use our calculator to get these answers. Alpha y equals -5 plus 13 over 6, and we get 4 over 3 for that answer. So x is 4 over 3. Scroll back up, and let's change that plus to a minus, and we get -3. So these are our two answers for this problem. Okay, so what you are going to be asked to do to get credit for this class is complete the practice page. Complete it on a separate piece of paper, and then you are going to have to upload a picture of your work and your solutions to Google Classroom. Sorry about that last part. All right, have a great day, everyone.